Hello everyone, am I audible? So is my screen visible? Someone please reply. Am I audible? And is my screen visible? Okay, let's start this live session. Okay, so I am Pankaj Kapri and I'll be taking live session of this Engineering Mathematics 1 course. This is week 3 and I have prepared some problems related to the lecture videos of week 3. And lecture videos of this week are based on the concept of differentiability of functions of one or two variables and total differentiability of a function, and further we have all these partial derivatives. Okay, let's start with the first problem. uh, to wait for some time. Okay, so I had opened the wrong file. This is the so okay, this these are the questions for this week. Okay, we start with the first problem. So the first problem, we have given a function, and this function is you can see that is x square times sine of 1 by x when x is non-zero, and it takes value 0 when x is 0. Okay, and we have to find out if the function is differentiable or not, right? We have these four options a, b, c, d, and we have to find which one of these are correct or not. So there can be more than one options can be correct. Okay, so basically we have to find if the function is differentiable at 0, derivative of the function is continuous at 0 or not. Okay, okay, so correct answers are a and d. So that is the function is differentiable at 0, and, and the derivative of the function is not continuous at 0. Let's see why. Okay, so f of x is equal to x square times sine of 1 by x if x is non-zero, and this is 0 if x is 0. Okay, we saw that the function is differentiable at 0. That is, we have to find if this limit exists or not. Limit of some h tends to 0, f of 0 plus h minus f of 0 divided by h, right? Now you can, because f of 0 is 0, so this limit is equal to limit of x tends to 0. Okay, so this is f of h. So what is f of h? Is h square sine of 1 by h and divided by h. This is equal to limit of h goes to 0. Cancel h from both numerator and denominator. We have h times sine of 1 by h. Okay. What is this limit? Can someone tell? Okay. So we know that sine of 1 by h is a bounded function, right? Because the sin x function always takes value between 1 and -1. Okay. So this part is bounded. It will be always between 1 and -1. And this h tends to 0 that we know. Therefore, this limit is 0. Okay. This shows that the function is differentiable at 0. And further, the value of f prime at origin is equal to 0. So this we have found. Okay. So we have found the value of the derivative at origin at 0. Now, because we have to also show that the f prime is not continuous at 0, we have to find f prime x, right? So if x is non-zero, fx is x square sine 1 by x, right? So f prime of x is, we can simply differentiate this function because this function is well defined whenever x is non-zero. When x is 0, we have already got our derivative. Okay. So what we get after differentiating, we use product rule. So this is our first function and this is our second function. Okay. So differentiate the first function, we'll get 2x. So this is 2x times second function, which is sine of 1 by x, plus first function and the derivative of second function. So what is derivative of sine 1 by x? Okay, what is the derivative of sine 1 by x? So d by dx of sine 1 by x. Okay. The derivative of sine x is cos x. So this is cos of 1 by x. Now we have to differentiate 1 by x also, right? Because it's a composite function. So we apply a chain rule. Okay. So derivative of 1 by x, we have to multiply it by derivative of 1 by x. So what is the derivative of 1 by x? It is minus of 1 by x square. Okay. So this we can do in the background. And the final answer is this is minus. And this x square will also cancel with this x, right? Because we cos x 1 over x square. Or we can write here only. Okay. So f prime x is equal to 2x sine 1 by x plus actually minus cos 1 by x. Okay. So this is our derivative f prime x. So f prime x is this whenever x is non-zero, and this is 0 when x is 0, right? We have already calculated that. Now you can see that this function is not continuous. Why? F prime x is not continuous at origin at 0. Why? Because since this part cos of 1 by x is not continuous. Okay. Therefore, option A and D are correct. The derivative of the function is not continuous at x equal to 0, but the function is differentiable at x equal to 0. Okay. So if there are any questions regarding this, you can ask. You can turn on your mic and you can ask. Okay, so if there are no other questions, then we just move to the second problem. Now, in this particular problem, the given function has two variables, right? The function of two variables, x and y. And again, we have to find which statements are correct out of these four given options for this given function. Okay, we have to find if either function is continuous or not, or it is differentiable or not at the origin, or its derivative does exist or does not exist. We have to find all these things. Okay, so we'll treat all these options case by case. Okay, the correct answers are A and B. So let's reveal that the function is actually continuous at origin, but it is not differentiable at origin. Okay, and we will see why. Okay. Uh, okay, so when x square plus y square is non-zero, the function is given as x square times y divided by x square plus y square. Okay, so it's x square y divided by x square plus y square. Okay, let's first say if function is continuous or not. Okay, so what we do, we just convert it to the polar coordinates, right? Because we know that in polar coordinates, x square plus y square is r square. Let x is r cos theta and y is r sin theta. Okay, as a function of r comma theta, this will become r cube cos square theta sin theta divided by r square, which is equal to r cos square theta sin theta. Okay, now the limit of xy going to 0 comma 0 of fxy same as limit r going to 0 of this fr theta. Okay, and this limit is 0, and which is same as the function value at 0 comma 0. Okay, the functional value at 0 comma 0 is this 0. Why? Because 0 square plus 0 square is 0. This says that a function is continuous. So f is continuous at x origin. Okay, now we'll show that the function is not differentiable at origin. For that, we'll first find what are these partial derivatives. Okay, the options C and D are false, so they are not correct. The option C and D says that the partial derivatives at origin does not exist, but that is false. We saw that the partial derivatives at origin exist, and we will find their values also. Okay, so now recall that. Okay, this just for recall that we say that the function f of two variable is differentiable at some point, let's say some x naught comma y naught, differentiable at this particular point if you write this increment, if you give x naught increment delta x and y naught little bit increment delta y, then you calculate this total change in the function. Okay, this is the value of function after the change when you change x naught by delta x and y naught by delta y, and this is the value of the function before the change, and this is the net increment, the increment in the function when you change the independent variable by small amount. So we say that a function is differentiable if this change delta z can be written as some constant times delta x plus some constant time delta y plus some function of plus some epsilon times delta x plus epsilon 2 times delta y. Here this a and b are constant, they are independent of delta x delta y, but epsilon 1 and epsilon 2, they are functions of delta x and delta y. So if we can write this increment delta z in this particular form, where epsilon 1 and epsilon 2, they both approaches 0, as your small increment delta x delta y, they approaches 0, then we say that the function is differentiable at that particular point x naught comma y naught. And further, these a is actually equal to the partial derivative of x with respect to x at x naught comma y naught, and b is partial differentiable at origin or not. So we'll just find that increment at origin. Okay, for our given function, because we want to check differentiability at origin, so we will just increase the origin by a small amount and we calculate the change. This is net change. Okay, now now the value of the function at origin is 0. This is precisely equal to delta x comma delta y. Okay, now from the definition of function, okay, so this is your definition. So what is f of delta x comma delta y? Is equal to delta x square, or we write this just as delta square x into delta y divided by delta square x into delta square y. Okay, note that this delta x square we are writing as delta square x. Okay, so this is some side note. Okay, what we will do, we will just write this equation as, okay, okay, again side note, note that we can write 1 is equal to half plus half. Okay, so any number or one can be break into two parts, two equal parts. In particular, one can be written as half plus half. So this particular quantity we will write as half of in two parts, in two equal parts. Okay, so in one of part we can write half of delta x delta y divided by delta square x delta square y into delta x, right? And another half we can write half of delta square x divided by delta square x plus delta square y into delta y. Okay, note that the constant which we have written in the previous example, these two a and b, they are here in this case they are 0. So 0 times delta x, 0 times delta y. Okay, because we can show that the partial derivative are actually 0. Okay, this fx 0 is also 0, and second fy of 0 is also 0. That we'll just see in the next slide. Okay, so let me insert a new page here. Okay, so this is a new page. Okay, okay, so our net change, now note that this is our epsilon 1, okay, as a function of delta x and delta y, and this is our epsilon 2. Now note that the limit of delta x comma delta y going 0 of epsilon 1, this does not exist. Why it doesn't exist? Okay, so in the definition of differentiability, we want that this limit should be 0. As delta x and delta y approaches 0, we want that the limit should be 0 of this the constant of this function epsilon 1 and epsilon 2. But in our case, what is epsilon 1? This is half of delta x delta y divided by delta x square delta y square, right? Now you can see that the limit of this function doesn't exist when you take this limit as delta x comma delta y goes to origin. Why it doesn't exist? Because this limit is path dependent, and that can be seen by just considering straight line paths. Consider these paths delta y equal to m times delta x, right? These are paths, these are straight lines origin. Okay, just put delta y equal to m times delta x, then what do you get? Epsilon 1 of delta x of delta y, where delta y we are putting as m times delta x, then this is equal to half of delta x square, and m can be taken out, and further this is m plus m square times delta x square. This limit is, this value is equal to half times m divided by 1 over m square. Okay, so if you take this limit delta x comma delta y going to 0 comma 0 of epsilon 1, then this will just become half 1 over m square. Okay, and we are taking this limit along the path delta y equal to m times delta x. Okay, so because this limit is path dependent, we have that this limit of epsilon does not exist. Okay, similarly limit of epsilon 2 also doesn't exist, and that shows that the function is not differentiable at origin. Okay, okay, and one more thing, I told you that f the partial derivative of this function at origin is 0. Let's calculate this one, and partial derivative with respect to y at origin is also 0. Let's just calculate the one of them. We'll just calculate the first one. Okay. So what is fx of 0 comma 0 by definition? This is limit of h going to 0 f of h comma 0 minus f of 0 comma 0 divided by h. Okay, so this is equal to limit h goes to 0 f of h comma 0 divided by h. Okay, because f of 0 0 is 0. Okay, now note that the value of function at origin is 0, and again f of h comma 0 is also 0. Why? Because you can see here the function is defined as x squared times y divided by x squared plus y squared, right? So whenever either x or y becomes 0, then the functional value becomes 0. Okay, so f of h comma 0 is 0. From here this can be seen. Okay, you just put value of y equal to 0 in the function. Okay, and hence this limit is 0 because the function itself becomes 0. Okay, so the last two options were false. This c and d were false because it says that the partial derivative doesn't exist at origin, but we know that partial derivative exists at origin and their values are 0 comma 0. Okay, so are there any questions regarding to this problem? Okay, so if there are no other problem, let's move to the next problem. Okay, so in this particular problem, you can see that a function is given, which is w, and w is given as x square plus y square plus z square. But further x, y, and z, they are functions of t, right? W is a function of x, y, and z, but x, y, and z are also functions of t. So this is a composite function, and you have to find the value of the derivative of this function w at t. You have to find that derivative at t comma t equal to 0. Okay. So let's see that what is this derivative. So the answer is C, but let's find out. So Z is equal to x square. No, it's not Z, it's W. So W is equal to x square plus y square plus z square, where x is equal to something and y is something and z is something. So what are these? So x is cos t, y is log of 1 plus t. So cos t, log of 1 plus t, and e to the power t. Okay. So what is dw over dt? Okay. So we'll just apply the chain rule. So chain rule says that first you differentiate your function with respect to x, and then you differentiate x with respect to t, because x is a function of t. Okay. So this will become the partial derivative of w with respect to x into dx by dt plus partial derivative of w with respect to y into dy by dt plus partial derivative of w with respect to z into dz by dt. Okay. So what are these things? What is the derivative of w with respect to x? To treat y and z constant, so you have to find the derivative of x square, which is equal to 2x. What is derivative of x? What is dx by dt? So x is cos t, so dx by dt is sin t, right? So this is minus of sin t. Okay. What is derivative of y, w with respect to y? It's 2y. And what is dy by dt? This is 1 over 1 plus t, right? Because the derivative of log is 1 over 1 plus t. Okay. So this is 2y divided by 1 plus t plus, again, derivative of w with respect to z, that is 2z. And what is dz by dt? Because it's an exponential function and derivative of exponential is e to power t. Okay, so we got this thing, but we have to find the dw by dt at t equal to 0, right? So we just put t equal to 0. So what is a value of x at 0? So value of x at 0 means cos of 0. So cos of 0 is 1. But what is sine of 0? Sine of 0 is 0. So the first term becomes 0. What is the value of y at 0? T equal to 0. So when you put t equal to 0 in y, you get a log of 1. But log of 1 is 0. So you gain 0. Now evaluate this expression at t equal to 0. Okay. So what is the value of z at t equal to 0? So z is e to the power t. Therefore, the value of z at t equal to 0 is 1, right? But then this is just e to the power t, so e to the power 0. So this will become 2. So final answer is 2. Okay. So option C is correct in this case. So any questions regarding to this problem? You can ask. Okay, let's move to the next problem if there are no other questions. So this is a simple conceptual question. Again, you have to tell which options are correct and which are false. Okay. So okay, first let's see the options C and D. Okay, we have to basically in the option C and D we have to find if the modulus function is continuous or not, or it is differentiable or not. Okay, so what is the modulus function? So let's say the graph of modulus function. Okay, the graph of this function. The graph of modulus function is like this. Okay, so this is the graph of this modulus function. You can see that f is continuous, but f is not differentiable. Why? Because at the origin there is no tangent line. Okay, and you can also prove that using the definition that the function f is not differentiable at origin. Only at x equal to 0 the function is not differentiable. Otherwise, the function is differentiable every other point. Okay, so the function is a continuous function is correct, but this is false. And then we know that the differentiability always implies continuity. If a function is differentiable, then it has to be continuous. Okay, that was also proved in the lecture videos, the first lecture video. So option A is also correct. What about B? So condition B, option B, it says that the continuity implies differentiability. That has to be false, right? Because we have this example of absolute value function, which is continuous but is not differentiable. Because of that, option B has to be incorrect. Okay, the correct options are A and C. Okay, so always note that the differentiability imply continuity. Okay, the differentiability is much stronger condition. When you have a function differentiable, then it has to be continuous. But the reverse argument, the reverse implication is not true. And why? Because we have this example, absolute value example, okay, which is continuous but is not differentiable. So if there are no other questions, then we just move to the next problem. Okay, so in this particular problem, we have to find the total differential of the given function. Okay, so this is your given function, and you have to find the total differential. Okay, so the correct option is C, and let's compute the total differential. Okay, so what I mean by that, my can speak. I didn't understand with your message in the chat box that questions may be bigger size. If you have any suggestion, then you can speak. Oh, okay. So you mean I should zoom it a little bit. Okay, that. So now can you read? So now is this problem is visible or clearly? I have zoomed a little bit. Okay. Okay, so let's first, what does we mean by total differential of a function? So if you have a function, let's say f of x comma y, okay. So total differential of this function, we mean by total differentiable of this function is given as del f over del x, the partial derivative of f respect to x times dx, plus the partial derivative of f respect to y times dy. Okay, so in our problem we are given that w is equal to, okay, so w is a function of x and y, so it's sine inverse of x over y plus tan inverse of y over x. Okay, and for this we have to find the total differential, that is we have to find dw. Okay, so for finding dw, we have to first find the partial derivatives of our function with respect to x and y. Okay, so let's recall what is the derivative of sine inverse and tan inverse function. Okay, so d by dx of sine inverse x. So this is equal to 1 over 1 minus x square, right? And the derivative of tan inverse x is equal to 1 over 1 plus x square. Okay, so we will use these derivatives. Okay, so what is the partial derivative of w with respect to x? Let's first find out that dw over dx. Okay, so we first differentiate this first function and then we'll differentiate this second function. But because these are composition of two functions, and we'll apply the chain rule. Okay, so first differentiate this sine inverse of x over y. So what is that? It is equal to 1 over 1 minus x over y whole square under root, and then differentiate x over y with respect to x, right? That is equal to 1 over y. Okay, now differentiate this tan inverse. For this we get 1 over 1 plus y over x whole square. Now differentiate y by x with respect to x, and that will be equal to minus y over x square. This is our partial derivative of w with respect to x. Let's see what is the partial derivative of with respect to y. Or let's first simplify this. We can first simplify that also. Okay, so when you simplify, you will get 1 over y square minus x square under root, and this y and y cancel with each other, minus, okay, so I did some mistakes. So here it is not under root. Okay, okay, the derivative of tan inverse is this 1 over 1 plus x square without under root. So that was the mistake. So this is x square plus y square and with a y. Okay, if you simplify that, then you get this. Okay, now let's find the derivative with respect to y. Again, same thing. Just apply the chain rule with this function and use the derivative. Use these two identities, 1 and 2, derivative of sine inverse and tan inverse. Okay, so derivative of sine inverse is, we have already seen, this is 1 minus x over y whole square into the derivative of x over y with respect to y. So this is x minus x over y square plus again differentiate tan inverse. So you'll get 1 over y over x whole square and then 1 by x. Okay, what is that equal to? Now simplify this expression. We get minus x divided by y square minus x square under root plus so is this correct? Okay, now just add these two identities. So dw is equal to del w, this partial derivative of w with respect to x times dx plus dy. So when you add these quantities, then what you will get? Okay, just add these two. This is dx minus x dy divided by y square minus x square. Okay, you can collect these fractions where there is a square root and then collect another fraction where there is not square root is not there in the denominator. You collect these things and write them separately. It is plus is equal to x dy minus y dx divided by x square plus y square. Okay, so this is the total differential of w. So let's see if this matches with the option C. So y dx minus x dy. Okay, the second term is same, but then there is a problem with the first term. Let's see. Okay, so you can see that here there is one more y, right? Because in the denominator we have y square, right? And from this square root you will just get y. So there is a y here in the denominator. So in the first term you just multiply in the numerator denominator both by y. Okay, so here you will have one y. This is y. Okay. Okay, so option C is correct. So this is the correct answer. So this is the difference. Okay, so because I'm writing on the spot, so I cannot copy questions. So the writing device which I am using, I cannot copy something which I have already written. So I have to write that again and again whenever required. But so if there are any other questions regarding this problem, then we can ask them. Okay. Okay, so if there are no other problems, let's move to the question 6. Okay, so in question 6, a function is given and you have to find if that function is homogeneous or not. And if the function is homogeneous, then you have to say what is the degree of that function. Okay, so out of these 4 options, you have to select which are true or false. So it's written that which of the following statements are, is or are false. Okay, so what is a homogeneous function? Let's recall the definition. What is the homogeneous function? So we say that a function or a expression in xy. So this is, definition is given in the lecture videos. Expression in xy is called homogeneous of degree n if it can be written as x to power n times some function of y over x. Okay, this is our first definition. And in second definition, we say that the function is homogeneous of degree n if f of tx ty can be written as t to power n times f of x comma y. Okay, in these cases we say the function is homogeneous. Okay, so for us, what is the given function? So this is our given function. Okay, let's see if we can, or given function or given expression, and let's see if we can write it in terms of x, some x to power n times g of y to power x. Okay, so what is our expression? This is x square y square plus xy cube plus y to power 4. Okay, what we will do, we will just divide the whole expression by x to the power 4. Divide by x to the power 4. Okay, but we will get x to the power 4 into, okay, when you divide x to the power 4 in each of these terms, you will get, this is y over x whole square, y square divided by x square, plus again this can be written as y cube divided by x cube, and this is y to the power 4 divided by x to the power 4. Okay, now we can note that this is x to the power 4, the function of y over x. Okay, this particular part, is a function of y over x. Okay, so what is g of y over x, or what is gx? Let's not confuse. Let's write g of w. So g of w is w square plus w cube plus w4. Okay, and therefore g of y over x is y over x whole square, y over x cube, y over x 4, which is exactly equal to this one. Okay, this says that the function, given function is actually homogeneous and the function has degree 4. Okay, so let's write the conclusion. Conclusion is fh homogeneous of degree 4. Okay, so which options are false? Option C is false. This is false. That degree of function is 3. It is false. The function is not homogeneous is also false. The function is actually, these are true statements. Okay, so false, true, false, true. Okay. Any question regarding to this problem? Okay, okay. So if there are no other questions, then let's move to the next problem. Okay. Okay. So you can see what is the problem. So here a function is given, and you have to find what is the value of this expression. Okay. Okay. Let's start answering this question. So for this particular problem, we will use Euler's theorem. Okay. So there is the result for homogeneous function. Okay. First, we just can you see that the function given function is homogeneous of degree 3. Function given here is homogeneous of degree 3. Why? Because f is homogeneous of degree 3. Why? Because x cube plus xy square plus 3x square y plus y cube. This can be written as, just take x cube common, and you can write as 1 plus y square over x square plus 3y over x plus y cube x cube. Okay. So because we can write it as x to power 3 times some function in y over x, the function is homogeneous of degree 3. Okay. And for such functions, we have a result. It's called Euler's theorem. Okay. You can directly compute this particular expression, but there is a simple method. Like this is already computed for you. The Euler's theorem says that if f is a function, a homogeneous function, of degree n, then this expression, whichever we are writing, this x del f del x plus y del f del y. Okay, this is precisely equal to n times f. Okay, this is Euler's theorem. Now, for us, the given function is homogeneous of degree 3. Is therefore, by Euler's theorem, we have x del f over del x plus y del f over del y is equal to 3 times x. Okay, so the option C is correct. Any questions regarding this problem? Okay, so if there are no other questions, then we can end our live session here. And please note that you will also get these slides and recorded video later on. Okay, so I'm also recording these meetings, and you will get the link, and I'll upload these videos on my YouTube channel, and you can view, you can see that video later on whenever you want. You can share it with your other friends or whoever. Okay, so all these things, they will be provided later on also. Okay then, so thank you everyone for joining this live session, and we will meet next time. We will meet next week with another set of problems for based on the videos of next week. Okay.